Talking about statistical significance now. We start with the null hypothesis, which states that there's no difference between the groups or no relationship among the variables. For example, the tested statement might be that there is no difference between the means of the two groups on some dependent variable, or that there is no correlation between the predicted and predicted variable, whether we're looking at differences or relationships. The concept of testing a null hypothesis is the basis for statistical inference. It underlines all the methods of testing differences and analyzing relationships. The null hypothesis. Statistical analysis methods cannot prove a hypothesis, but they can disprove them by demonstrating their unlikelihood given the evidence provided. A null hypothesis claims the reverse of the active hypothesis. The decision is made to either accept or reject the null hypothesis. When the null hypothesis cannot be refuted, that means the statistical test cannot prove the hypothesis. And you are wrong. So the null hypothesis testing is similar to the legal presumption of innocence. The defendant is considered innocent until proven guilty. The prosecution must supply compelling evidence to prove guilt beyond a reasonable doubt. The null hypothesis is presumed to be valid until the researcher can demonstrate that the data contradict their assumptions beyond a reasonable doubt. With significance to testing, we're determining whether the data contradict the null, whether your hypothesis is correct. Type 1 and Type 2 errors. When a researcher makes a decision about a null hypothesis, one of four things can happen. The hypothesis can be true, the hypothesis can be false, the researcher can accept it, or the researcher can reject it. There are two possible correct decisions that the researcher can make. The researcher can accept a true null hypothesis or reject a false null hypothesis. But then there are also two possible incorrect decisions that the researcher can make. They can reject a true null hypothesis, that's called a type 1 error, or they can accept a false null hypothesis, which would be a type 2 error. If a researcher concludes on the basis of a sample of data that the two groups are different, then the decision will be correct if the groups are different, or a type 1 error if the groups are not different. If the researcher concludes on the basis of the sample data that the two groups are not different, then the decision will be correct if the two groups are not different, or it'll be a type 2 error if the two groups are actually different. Statistical analysis helps the researcher make the decision about the null hypothesis. It indicates the probability that a decision to reject the null hypothesis is a type 1 error, or the probability that a decision to accept the null hypothesis is a type 2 error. This is important, the level of significance. The level of significance is the probability of making a type 1 error. It's sometimes also referred to as the level of confidence. It could be a between-group comparison of the means on some dependent variable between the two groups of subjects, or it could be a within-subject comparison, a comparison of the means on some dependent variable of the subject tested under two different experimental conditions. The most frequently used levels of significance are 0.05 or 0.01, and you'll see this in your papers. It means the probability of committing a type 1 error is 0.5 or 5 chances out of 100, or even stronger, 0.01, 1 chance out of 100 of committing a type 1 error. It indicates that the difference between the data sets could have resulted by chance if the null hypothesis were true, only 1 out of 100 times. So the null hypothesis is rejected, your hypothesis is accepted, and the difference is called the significance level. So 1 out of 100 chance that your result occurred by chance. The level of significance is indicated using a letter P for probability. The difference between the groups was significant at a P of 0.05. A P level of 0.01 is stricter, more conservative, so your data is even stronger if your p-value is 0.01 as compared to 0.05. The smaller the number, the less of a chance that your results actually occurred by chance, the stronger your data, the stronger your results. Finally, you might see degrees of freedom. This is part of the sample size. It's necessary to interpret the results of a given statistical procedure. It indicates the number of values in the set that are free to vary once certain characteristics are known. If the mean or the sum of a set of scores is known, then the degree of freedoms are equal to the number of scores in each distribution minus 1. This is always important. Degree of freedom is usually reported near your level of significance. So the amount of variables the values that were free to vary once all the characteristics in the data were known.